Get my feet up over here.
Alright.
Buffering, huh? Okay.
She says there's no buffering issues on here.
Cool. Welcome to Make Something Voxelnauts. I believe this is our third episode, and today we're going to be doing entities like monsters, mostly monsters. There's that. Should be pretty good. You get my spreadsheet up. I have a spreadsheet. So in order to get as many of these in as possible, we started working last night for a few hours, and then this morning on just coding up all of the different entities. We have like, and we're going to code one live as well, but we wanted to get as much of the art that we can, and each one takes about 15 minutes to a half an hour to do, and there was like a dozen of them, so I don't even think we got through all of them, but we got through a fair number of them, so it should be pretty good. And well, I guess we'll start relatively soon. Dock here. Let's see. So we got a couple cool art assets in. This is the same level we were playing at the other day. So we got the rock block over there, and we got the cock block here. That we made last week, as well as a bunch of other blocks. I'm sure it's still in my inventory. Sandcastle, etc. And if you haven't seen that, Make Something Voxelnauts, you should check it out. It's pretty cool. Right. So the first thing we're going to show is the bass skull, which I believe was the badass skull or something like that. This is one that we coded up last night. I think James did the coding on this one. So you have this kind of like skull that just kind of like floats around in the air, and you can kill it. Let's spawn a couple of them. I believe he used the same code as the bat for this. Ah, whole tab laziness. Alright. Cool. And the next one is the ghost. You could do the ghost or the egg exterminator. Do the ghost, I guess. This one was pretty cool. This one I think Punk animated, and similar behavior to the one before. Where it just kind of like flies around and does this funny little animation. And let's see. Really what you'd do is you'd give them more health than one hit, one kill. You'd probably make them do some kind of attack animation too. That was pretty cool. Definitely like at night I could see that one being pretty darn scary, if in the right setting. And then there was the rabbit bike. This one's pretty funny. I did this one. It's a rabbit on a bike. Again, animated by Punk. He just like... But yeah, this one took like, you know, a few minutes at most. It wasn't very long to put this one in. The animations probably took a little bit to do. We were going to release the animation tool, but after Punk played with it for the first time, we decided it wasn't really ready for, you know, the public, because it was just a little clunky. It was very clunky. And then, you know, we would have to be playing support and like, oh, how do you do this? How do you do that? And, you know, because there's various different issues with it that you'd have to work around, and etc. But we will be releasing the animation tool pretty soon after the Kickstarter. Let's see, and then the other one was the Yandir. The Yandir was done just this morning, just like not, I believe. And this one is just, I think Punk just like put 3 of them there and animated them. I think she was trying to make them flip. Yes, all he wanted to do was ride his bike. Let's see. And then We got the bunny. Oh, and this is a pretty messed up bunny. I think he will actually attack you. No? No, he just bounces at you. Boom. Let's see. Critter? What is MSV critter? I guess we'll see what that one is. I didn't make all these, so. This one, oh right, is also like the same kind of behavior as the last one. Saving the best for last. Maybe. Oh, right, there's the floppy drive, the tiki mask, and the snake to do left. And then there's the hard hat and the egg exterminator. So we'll try the floppy disk first one. I've never spawned this one before. This one's gonna be new. We'll see if this is any good. Should be good. Floppy. It's just a floppy disk. Nice. Oh my god! Take your 1.4 megabytes and take them away! Get them out of here. Of course, it has to be a red one. It should change color. Maybe we could do that real quick. Let's see. Going back to the spreadsheet. Tiki Mask also, haven't spawned this one yet. James did this one too. Tiki Mask. We should probably, yep, same kind of behavior. But yeah. Weak. Weak. Hooga booga. Hooga booga booga. Cool, be cool if we had sound effects for all this stuff. He was clearly right protected. Snake. Oh, right. So, let me spawn this one again. So this is the solid snake box, and I believe it's like a pickup where you can just go over and pick it up, and then you go in your inventory and you have your snake box, and then if you select it, you can just creep around, which is pretty funny. Let's see. All right. And let's see. That was pretty good. I saw that one last night. And the next one is, let's do the eggs Terminator first. Oops. And basically, Punk animated this one, and the funny thing about this guy is that he has this, like, you can't really see it because he's always aiming at me, but maybe if I get out of his aiming radius, we could stop it. If I can get out of his aiming radius. On his back he has a butt plug. Pretty hilarious. But yeah, it's a pretty cool model. And I set him up so that if you use it, Like if you press the use key on it, the entities destroy. So I don't have to kill that one. And then oh, then the hard hat. Hard hat's pretty awesome. You're gonna like that. Oh. And then this is like an old Mega Man style hard hat. And so now we're going to code one live, which should be pretty fun. Certainly will be interesting. First, I pre-coded this one just so I could do it without boring people. So what I'm going to do is I'm going to delete all the code and then I'm going to actually do it live. Okay, so let me first talk about a little bit about how the code works without trying to bore people too much. Let's see. So the code is basically broken up into a bunch of different things. If you can't, can everybody read this? Can you read this? Everybody read this? I guess I have to wait for the buffering to catch up. Okay, cool. All right, so basically there's three different pieces of state. There's like cgame private, game private. Cgame private is client state, right? I think I may have covered this slightly in an earlier segment, but I don't remember if I did. But cgame private is data that is only available to the client. Game private is data that's only available to the server. And network private is data that is synchronized between the server and the client. So if you put something in here and something's running on the server, that gets automatically transferred over to the client, you know, properly delta compressed and everything like that, so it's low bandwidth. But, cool. So, the first thing we're going to do, oh, right. And then there's like client-specific callbacks, right? This is like like if you would have a void main, right? Void main is called by the operating system. Well, these are our points that the engine in particular calls into this program. There's events, messages. Messages are kind of like a way to communicate between entities. Events are for like instantaneous responses. So like if you swing your sword, you don't want to have to wait for the server to get the message and then actually, you know, pass the stuff on to the client. You want the client to swing a sword immediately and process all feedback for that immediately, including feedback with other entities. And so you can swing the sword, you see the sword swing, and you see the impact of it, and then the server just confirms that the sword swing happened at that point in time and that the effects were correct. And if they weren't, it corrects it. And that all just kind of happens like fairly automatically. You don't have to worry about the correction of how all that works. Again, messages are just for communicating. Update client just happens like once a frame. You know, like we're going to be editing this function, so like, you know, once called once per frame on the client. And init clients, let's just do it like this. Init client is called on scoping, basically. So what scoping means is like when, say, an entity is outside of the range at which the client would see it, right? Well, when it first comes into that range, right, whether it is spawned into your range already or you walk into its range, it calls init client when the client first gets the data. And so typically what you do here is you do any kind of initialization or of your C game private up here, or on things like that, initializing assets and things like that. Normally, you don't have to initialize assets too much, but in case you do, or data, you can do that. And then on the server, similarly, you have events on the server. Dave right now is currently coding up more entities. So we're going to be having more and more entities showing up as we go on through the stream. But I'm just kind of like going over like the actual programming of one, so you can see it kind of happen. So typically you just pound include entity.h, which includes all of the necessary information. Also, right here, what we're doing is we're including the walk animation, and if we open that up, so this is the animation data that's exported from the animation tool. And what you have is, for the animation data, you have like a list of Vox files, its pivots, its scales, and stuff like that. And then you have a bunch of frames. For each bone, there's going to be a frame, and this is in hierarchy order. But you have like, what's its parent bone, you have the Vox, you can't see my finger. But you have like its parent bone, its Vox file, the actual bone data, which is a quaternion, a scale, and a translation. And this is hierarchical, right? So you have all the various different frames or whatever. And this is like just the raw animation data. And then down here you have a structure. And if you notice, this is in this is using C style initialization, which you can't do in C++, which is a real pain in the butt, because this is actually one of the coolest features of C, in my opinion, is this designated initializer stuff. But I suppose maybe you don't care about it. But I think it's really cool. But yeah, this hooks up the previous data into this structure right here, and that's how the animations are exported. We're also going to support animations in a separate file, which will come in handy in specific situations, but this is really easy to just quickly put animations in the game. Let's see. So if we go in, so back to this. Okay, so update server. This is once per frame on the server, and then this is called once when the entity spawns. Okay, and the terminology here is that spawning means like when the entity first comes into existence, like another entity spawned it, right? Cool. And so let's start doing something interesting. Now that you have the general overview of how these entities are written, we pound included the animation, which is going to come in handy when we want to render the entity, which is the very first thing we're going to do. So, so in order to render the entity, first, we have a skeleton, right, which is the bone structure for this particular thing. I'm going to call that skell, and we're going to do anim render. Does the skeleton go first? Shit. See, this is what I have. And this is anim walk time f, and then so time f is like just a floating point number, which is time increasing. That's just like how many seconds have passed, Let's see. Right. So we're going to use the default animation playing, whether it's looping or once or mirrored or reverse mirrored, etc., etc. There's all different ways to play an animation. There's all different ways to play an animation, and but we're just going to use the default, which is whatever the animator specified, which is looping in this particular case. And then we're gonna animate this into the skeleton that we just have right here. Oh no, it's not render. That's what it is. Yeah, animate, and then okay. But in order to, and then we're gonna render this character that we just animated, right? And in order to do that, we do anim render, and we have to specify, I think, an X form, and then a color, and then, yeah, no, oh, first we specify the skeleton. We want to render this skeleton with this transform and this color. The transform is like where it's in the world, how it's oriented, what its scale is. It's just a 4x4 matrix, so it's, you know, you could do all sorts of stuff with that. We specify this parameter is probably going to go away at some point because I don't think it's necessary anymore. But then the last parameter is 0, because I forget what that is. Oh, maybe that's like ignoring something, I forget. That's probably just the flags. Okay, so now we specified a transform and a color. We don't have that specified anywhere or created, so we're going to have to come up with it. And for the color, and we also need a transform. We need to actually get this information from somewhere. So for the color, what we can do is we can do trap get light at, which I believe, yeah. We specify where the origin is, and then we specify what we want to put it into. Now the origin is like where the entity is located in the world. So we're saying, give me the light at this particular spot in the world, and put it into this vec3t. And a vec3t is just another name for float. It's just a type def to float color 3. That's all it is. And so, so this is nothing special or magical or anything else going on here. This is just straight up C code. And so for the transform, similarly, we're going to do map 4x4 transform 3v, and we're going to do int s.origin and xform. And what this is going to do is it's going to create a matrix, right? Yeah. And then we're going to do a map 4x4 rotate y. And we're going to do int s angles 1 and oh wait, input matrix, output matrix. And what that's going to do is that's going to then orient it along the direction that the entity is facing. It's not really that much API. It's no more than you'd have to learn in any other system. Let's see, and then that's it. I think that should just work. Let's see if it does. Right now I'm binding F1, so I can just recompile this by pressing the key. I got some compilers, so take a look at it. It's invalid in C99. Oh, okay. So I specified that wrong. How did I specify that wrong? Oh, not transform, translate. That's what I get for going by memory. And then the next one is rotate underscore y. Right. And this last one is welcome to the fun of programming, right? Use of undeclared and in-play default. I spelled it wrong somewhere. Oh, yep, I spelled it wrong. Alright, now we'll do bind q spawn msv dino. And then q. And there we go. We have our dinosaur. Just like that. And he's animating, walking, and playing his walking animation. So that's really all there is in order to get something into the game. Maybe we could create some helper functions to make this a little easier in the future, a little faster than having to know all these various different API calls. But I would encourage you to try to understand the API calls anyway, because it'll help you learn more about what's going on in the code. In init server, there's just some basic generic stuff that you have to do. We have to say, oops, it's like a contents body, and what this is going to do is this going to say, that contents body means that I can interact with it, right? That's basically what that means. Linear dampening is kind of like a terminal velocity. Gravity scale is how much gravity there is. Step size, we're going to say it can walk up 1 block high. It can't block up 2 blocks high. It can't block up half a block high. And that's just a convenience, so we don't have to make them jump for this particular stream. Although most of the time you probably want to do jumping rather than just having him like walk up a block, as if he could step up it. Entity bounds, we're just going to use whatever the default is for this particular entity, which is 11.45 or whatever. And then we're going to reset the angles 0 and angles 2 so that it's actually the correct angles. Or actually, we don't really need to do that in this particular case, because we only use the Y. But then I just recompiled it and got those things, but let's get... I'm going to put that in update server so it gets called every time. And then I'm going to go out, and then the next thing we got to do, which I'd like to do, is if you use the object, if you interact with it, right? If you press the E key on it, I want it to delete itself. And so we call trap remove entity on ent ID, which is itself. If I can. Oh, but he's all messed up. Love it. So I did this in the wrong order. Let me just have it remove itself and update it. Alright. Alright, so what I did right there is I just removed the entity by itself. Now I can put him down, and you notice that he fell to the ground in this particular case, where he didn't before. And that's because we added gravity and a bunch of other basic physics. And this is using the default physics setup, which you could override if you really wanted to. But the default physics setup is useful for, I'd say, 99.9% of all cases. Let's see, are there any questions going on here? I should probably be paying more attention to the chat. Yeah, you know, after we implemented this, I thought back about it too, and I'm like, you know, this is really similar to Quake C. And then, like, from the original Quake, you know, as kind of like the ideal way to set up entities. And then I looked at the original Quake C, and I realized that we're, like, significantly better than that, as far as, like, how we've set it up. But that's because, I think mainly because Quake C was, like, not using... well, a real compiler. It was kind of like the small c or whatever it was that he coded up specifically for that. And I'm going to turn the light on. It's kind of dark in here. But it's using small c and stuff like that. But, you know, since we have like a real compiler, we're able to do some things. And using C99, which didn't exist back then. And you know, we're able to do some things that Quake wasn't really able to do because it wasn't really feasible back then. And so, but yeah, no, I could see the similarities of that. It'd be pretty cool. Let's see. So let's make him move around, shall we? That's like the next thing you want him to do. And for moving him around, basically what we did earlier is this code right here. What I did earlier. I think that's like the last step, right? Yeah, it is the last step. So in order for it to move around, you want a target for it to move around to. So we're going to specify that right there, and we're going to say, oh well, the initial target is itself. So we'll go move vec3 copy and s to origin. So we're going to say your initial target that we want you to move to is right where you are. And what we're going to do is we're going to figure out how far away we are from the target, and if we're closer than some amount, we're going to pick a different target. So this is basically going to make him walk to a specific place, and then once he gets there, change direction and walk somewhere else. So he's just going to wander around the map. So in order to do this, we're going to do vec3 subtract, and we're going to do, let's see, s.origin, and then yeah, and then we're gonna. Okay, so basically what I'm doing is I'm taking where we're moving to and where the entity is located, and I'm subtracting them to get like the vector that goes in between those two. And then I'm gonna set the y-axis, which is the up axis, to 0 because I don't care about the z. I don't care about like the up down. I only care about how far in x, y is he away from his target. Which is important because if he walks up a step, then there's still going to be some up-down distance that that was there to his move target that we don't really want to care about because because then he'll never actually be able to reach his target. So the next thing we want to do is we want to say if the length of the direction is less than 1, or, oh, let's keep it like that. We'll keep it simple first. And then, meaning like if we're within 1 meter from our target, let's just consider us, hey, we got there. And then if that's the case, then we need to pick a new target. And by picking a new target, we could basically just say, I'm going to take the current target and move it by a random location, by a random amount, sorry. And yeah, vec3, yeah. It is vec3 rand, isn't it? Yeah. And we're going to move it in a random amount between in this -2 by +2 box. We're creating a -2 by +2 to 2 +2 random vector. Which we're going to store in the R vector, and then we're going to add that to nt move to, was it NP? No, SWP, right? Oh, you're right. My earlier self was smarter than myself, my current self. So, so basically what I did right there is I realized that we really only need the move to vector on the server. We don't need it on the client at all. And so I moved it from the shared network state into the server state. And that'll save it on bandwidth and stuff like that, so, which is good. Let's see, let's add R to ntp move to. So we're taking the current target and we're moving it in a random, randomly 2 meters away from where it currently is. And then I believe, yeah. And then what we're going to do is we're going to do vec3 subtracts. Is it origin first? That doesn't make sense. Yeah, that's right. No, that doesn't. Okay, so now we're taking the new vector location. We're subtracting out the origin, so we're just looking at the difference between where it's located and the new target. And then the idea is that we're creating a random offset from where he is. So he's not completely changing direction into like the opposite direction. We only want him to change direction just a tiny bit, either left or right, but not like completely backwards, unless that's the only way to go. Because if he just walks in some random location every time, that's going to look a little funny. It's not going to look right. I mean, we could do that at first, I suppose, just for an example. But, whatever. And, and then we're going to normalize the move to vector. Right. And then, basically what we're going to do is we're going to say, we're going to take the move to vector, which is normalized. And normalizing means that the length of the vector is now 1. So it's basically, no matter how big it was in any direction, we're putting it on a unit sphere. So it's always going to be like on the sphere away from like the 0, 0, 0 point. So it's exactly on that sphere. And what we're doing is then we're going to take that unit vector, we're going to multiply it by 7, right? So we're going to say, oh, actually your target is in this direction, but 7 units away. And then we're going to add that to the origin. So that's what this does. The first parameter is the origin, and this is a mad. And basically what the operation this performs is equals plus that's basically the operation that it performs, in that it takes the origin and then it takes the origin and adds move 2 times 7 and stores it in move 2. And then what that does, let's see. Okay, so that is all we really need to do in order to create a new movement vector. But like I said, this is just in order to get a more nicer vector. We could have done something a bit more crude in order to just get something up and running, I suppose. But this is just to get a more nicer, vector. But let's see, vec3 normalized. Again, what we're trying to do is we're trying to say the direction. We're trying to take the direction that we're trying to move in, which is this vector. Oops, which is this vector from up here. And we're trying to normalize it so that we get just the direction of the vector, so it's on the unit sphere again. And now what we're going to do is we're going to say this direction and scale it by 10. So we're saying we want to move in that direction at a speed of about 10 meters per second or so. Oh, that's all right. How does force work? Oh, right, because of the friction, that's actually not necessarily the case. If it was in the air with no friction, it would be 10 meters per second. But the force we're going to do is about 10, and we're going to store it in force. And what force does is inside the physics system, it computes that as the direction it wants to move, and will correctly apply acceleration, velocity, and et cetera, and so on. So we're applying a force to the entity, saying go in this direction. Right. And then then he should just walk around, assuming I didn't have any code bugs, and he does. And he just walks around. And of course, this is all cool and everything like that, because that's kind of what you want. And he's just walking around. There, now he's walking in a different direction. So he gets to close to his target, and then he walks to a different direction. And this model was made by Zach Soares, also known as Y2B Crazy. But yeah. Now, if you notice, the next problem that we're going to solve is that he doesn't face the direction that he's walking. He just kind of like walks in a particular direction, including walking backwards, which makes no sense, right? And so we can fix that next. Right, he's walking in the wrong way. Right. So, the next thing we're going to do is actually make it walk in the right direction, which is actually easier than it might sound. So, what we're going to do is we're going to change its yaw, and yaw is like the direction that he's looking. And we're going to set that to be equal to the yaw that he should be facing for that particular thing. So if we do atan2f, there's a handy math function for doing this, which is called atan2f. And you could just specify dir0 and dir2, which are like the axes other than. You specify the axes other than the one that you want to find in order to get the direction. So in other words, you have this vector, right, which points in some direction. You're saying, what's the yaw for this vector? It could be pointing any which way. And you want to know, like, what's the yaw according to this particular vector. You can use atan2f and specify the x and the z in order to find the yaw. And if you were trying to find the pitch, you'd specify, you know, the y and the z because you're looking for the x, and et cetera, et cetera. But that's the general idea for that. And then I think he may have fell off the cliff. I think he may have totally just walked off. So I guess we'll have to spawn a new one. So we'll go up here. Oh no, there he is. Is he stuck on something? Oh, okay. And now he should be always walking where he is, but he's going to be walking backwards. And he gets caught in a tree. That's the other issue we're going to have to solve. So, how do you make him walk forward? Well, you rotate him by 180 degrees. Basically, the model was made backwards. So, but that's not a big problem. That's pretty easy to fix in code, which we will just do. And so we're going to go in the code, and we're going to say, oh, okay, this is where he's rotated. We're just going to add pi, which is 180 degrees. And so look, now he's walking forward. Simple as that, really. Oh, and he's trying to walk up the cock block. That's great. So let's see. But there's that. And is there anything else left to do? Oh, right. We want to fix the stuck problem, which is actually like this particular problem right here, which is actually not too hard. Basically, what we're just going to do is we're just going to check to see his velocity. The length of his velocity is less than the some amount, which basically means he's trying to go in a particular direction, but he's being totally unsuccessful. And boom, just like that, it's fixed. You just change the code, press F1 to recompile it, and you can instantly see the changes. And this is changing on the server and the client at the same time. So, like, it just synchronizes and it just kind of works. Let's see. But that's that. That's basically Mr. Dino. We can make him run faster. It looks kind of like he's in slow motion. So in order to make him run faster, we're going to take the animation times 2. Times 2. Look, now he's walking a little faster. Cool. But there you have it. We just coded an entity from scratch in Voxelnauts, live, on stream, with a bit of pre-preparation, so it wouldn't be very boring. But honestly, you know, that maybe only saved like 15 minutes or so. But still pretty cool. What? What? Oh, you want me to do Proto Man? All right. Apparently, Dave made Proto Man while we were doing the stream. So I guess we'll look at Proto Man real quick.
Snake off. Oh, he did. Yeah. Yeah, he did. I'll have him do it. James wants to see Snake again.
You want to see Snake again? Has he missed it earlier?
Yeah.
All right. I have him in the inventory still.
He's showing it right now.
Um,
Oh.
let's see. So, protoman.c. So you just want me to recompile Protoman, and now I should be. Dave just like checked in this thing, and I just pulled from the repo.
I checked it in like 20 minutes ago.
Protoman, and there's Protoman.
Attack it with the sword.
All right. What did he do? Oh, nice. Nice one, Dave. Nice.
It's funny. Just like in the game, when you kill him, he just slips away.
Okay, question and answer time. That was basically all it is. So, any questions or anything? Is there much setup with your code toolchain? No, you just, like, Dave literally just checked in a C file, and we literally just pulled it into the game right now. It was like that. You don't really have to do anything other than just put a file in your directory, which would be on the server, and it just works. Yeah, you're a bit late, Jen. We just finished. What's the theme for next week's Make Something Voxelnauts? I believe we decided that just before this stream, and I believe the idea was that we would do like was it like an encore?
Oh, she said it was a best of.
A best of?
A free for all.
Best of free for all. So
if you
yeah,
don't want to make anything.
So make anything you want to make, and we'll throw it in, and it'll be lots of fun.
And we'll
and
allow
there's
some banana sodas.
And it's the rock block. Yeah, no, there's looks like. If it gets funded in the alpha beta, you should expect to be able to play lots of different planets made not only by ourselves but by other people, and so you'll be able to get to play Oasis and Hyperion, hopefully, and a lot of other cool stuff. Hyperion is a PvP planet where there's a bunch of fortresses. For example, if you check out the world drifting video, you drift into a Hyperion stronghold, and what teams of people can capture these strongholds and then defend them and then expand, like factions can expand and capture other strongholds. And in each stronghold, there's going to be unique weapons and abilities that you can get for each particular one, and then combined with different strongholds that can make some pretty awesome combinations. And the idea is that you fight for kind of like world domination. Should be really awesome and lots of fun. Yes, there were VR support. I was just demoing VR earlier this week, actually. Punk asked me to put together a VR video where we could show VR live, or recorded, I should say. And so we'll probably be doing that real quick too. I mean, not that you're going to see anything other than a screen with two eyes. I don't think that's going to be very interesting. But if you guys want to see it, we could do it. It's no big deal. Yes, it was. It was inspired by Stargate SG-1. Anything else? Cool. All right then. Well, if there's no other questions, then I'm gonna grab some lunch, and everybody have a great weekend, and I'll see you next week. Bye, everyone. I have no idea where the dino went to.